for a number, finding the number of factors of 3600, right? So 3600 can be written as 36 into 100, right? And this is not a prime number. 36 and 100 are not prime numbers, so we have to convert this to a prime number product, right? So we can further break this down to 9 into 4, and 100 can be written as 25 into 4, and 4 can be written as 2 power 2, and here also there is a 2 power 2, so this will become 2 power 4, right? And 9 can be written as 3 square, and 25 can be written as 5 square. So now 3600 is converted into powers of prime numbers, right, which is 2, 3 and 5, right? So now it is very easy for us to find the number of factors, so we have to increase the powers by 1, right? So firstly, this 4's power is increased to 1, so into 2's power is increased to 1, into this 2's power is increased by 1, right? So 5 into 3 into 3, which is nothing but 45, right? So for larger numbers, we cannot simply write the factors one by one as we did for 12 here, right? So like this 12, we cannot write all the factors for 3600, right? So that is the reason we are using this trick to find out the number of factors of any number. Let's move to multiples. A multiple is a number which is generated by multiplying the given number with some integers, right? For example, let's take number 10. The first multiple of 10 is 10 itself, right? 1 into 10 is 10, right? 2 into 10 is 20. Similarly, 30, 40, 50, 60, etc., right? So multiples are infinite, right? We cannot say this is the last multiple of this number. It keeps on going, right? Let's take another number 15. So its multiples are 15, 30, 45, 60, 75, 90, etc., right? So these are the multiples of 10 and 15. So what are the common multiples here? We can see 30 is a common multiple, and 60 is also a common multiple, and it keeps on going, right? So the common multiples are 30, 60, 90, etc. So what is the least common multiple? 30, right? Very simple. Can you tell what is the highest common multiple? No, right? So the highest common multiple would be infinity, right? Similarly, in case of HCF, the least common factor, right? The least common factor for any set of given numbers is 1, right? Because for all the numbers, 1 is a factor, right? So the least common factor for any number is 1. So this is how we find LCM and HCF, right? So let's move on to LCM using prime factorization method. Take numbers 60 and 72. Firstly, prime factor is 60. So this can be written as 2 into 2 into 3 into 5. And 72 can be written as 2 into 2 into 2 into 3 into 3, right? When you look here, 2 is a common number in both this, and another 2 is common, and there is a 3 common. So we cannot find any other common number. So as we did for HCF, we'll take those numbers which is occurring common in both the numbers, we'll take it for once, right? So this 2, this common 2 is taken for once, and this 2 is taken for once, and this 3 also. Then we'll take the remaining numbers also, 5, 2 and 3, right? And we'll multiply that. This is how we'll find the LCM, right? So which is equal to 360. So this is the method to calculate LCM using prime factorization method. Also, when you notice here, HCF is 12, right? So we'll take this 2 and the common 3 itself, right? So which is 12. When you notice something here, the LCM into HCF is 12 into 360, which is nothing but 4320. When you compare this with the given numbers, 4320 is nothing but product of 60 and 72. So we can say LCM into HCF is equal to product of the numbers, right? So this is a general property of LCM and HCF of given two numbers, right? Very important note. This rule is applicable for LCM and HCF of two numbers only. Let's solve an example in this case. The LCM of two numbers is 150 and their HCF is 10. So LCM is 150, HCF is 10, right? One number N1 is 30. We want the second number, right? So by the property of LCM and HCF of two numbers, we know that LCM into HCF is equal to product of the numbers N1 into N2. So 150 into 10 is equal to 30 into N2, right? So cancel out 0 and we cancel out this 3, this is 50, right? So the second number is nothing but 50. So that's all about LCM and HCF.